Okay, so already we discussed the circuit diagram is only this. Just in one channel you are connecting the LED, and this LED, what we are trying to do is we are going to make the LED on gradually on. It means the brightness slowly, initially it will be off, slowly like it will become on, and over the period it will become maximum brightness. And what we are going to do, again brightness we are going to reduce. So the brightness of the LED slowly, like we are increasing from 0% to 1, 2, 3, 4, 5 up to like a maximum 100, and again from 100 to 0, 0 to 100 and 100 to 0. The percentage of brightness of the LED we are increasing and decreasing. Got it, right? That's what the experiment today we are doing it. So for that, coming to the program, so you have to these two lines, no interrupt in this. Okay, just like it straightforward. So these two lines already we know, and this is one function. So this function, what it does is, the duty cycle is how many bit value? It is a 10-bit value, correct, right? So 10 bit means how many register it will be? Two register we need. Okay, so these two register is CCP R1L. Okay, let's take, this is your 10-bit value. Let's take, this is your 10-bit value. Okay, so here what will happen is, these 8 bits will go into one register and these 2 bits will go into another register. Got it, right? So this 8 bit will go to CCP R1L. Got it, right? So this CCP R1L register completely, the second 8 bit, I mean from 3rd bit to 10th bit will be stored in this CCP R1L. And these 2 bit will be stored in CCP 1 con register. In this, again, in this you have 8 bits now. Got it, right? In this 8 bit, you are going to store on this place. Is everybody getting right? So total we have a 10-bit number. So whatever 10-bit number is coming here, the duty cycle, the 10-bit number, that 10 bit you are going to put it in the right place. Got it, right? Where you want to put, assume that this is your 10 bit. So that 10 bit, second 8 bit, I mean from 3rd bit to 10th bit, you are going to put it in the CCP RL register. You see here, the DC, whatever you are, the DC you are doing right shift by 2 times. So once you do right shift by 2 times, what will happen? These 2 bit will be removed. So this 8 bit will be going to the beginning, and that 8 bit you are putting in this register. This register is a 8 bit register. So you are putting that 8 bit into that. Clear everybody? Any confusion in the first line? Okay. Next 2 line is, these 2 bit you are trying to put it here. That's all. Next 2 line is just only you are trying to put it here, and you are trying to make sure you are not disturbing any other bits. In CCP 1 con you should not disturb these 2 bits, and again you should not disturb these 4 bits. Only these 2 bit has to be exactly placed in this 2 bit position. Okay. So for that only these 2 lines we are doing. That's all. Very simple bitwise operation. So today you do this experiment. Okay. Whatever, even if I explain also the same process only. Just you take that and do this experiment. Nothing concept. Just like a bitwise operators. Got it, right? So this is already we put. This is just like you are doing some like a bitwise operation, and then you are putting in that CCP 1 con. Okay, clear? So this function is some 10-bit number is coming. The 10-bit number you are putting in that 2 register. The 10-bit number is 3-bit to 8-bit you are putting in CCP R1, and first 2-bit you are putting in the CCP 1 con 4th and 5th place. 0, 1, 2, 3, 4, 5. 4th and 5th place you are going to put that 2 bits. That's all. That is the purpose of using this function. Function itself, set PWM duty cycle in the appropriate register. Is everybody clear with the function? Okay. Next, coming to main function. So in main function, again, this channel is CCP1 channel is in which port? In C port. In C port we are connecting one LED. So that the C port I am configuring it as a output port. Okay. Yeah. After that I need to do configuration for the PWM also. Otherwise it will act as a just output channel. Got it, right? So just since I am connecting one LED, so we are expecting in that C port we are expecting the output voltage. And after configuring it, again now I am going to do the configuration for PWM. You have to do both the configuration. Got it, right? So now these 3 lines are PWM configuration. Okay. I will come to this 3 line afterwards. So here we are configuring the PWM. Now you are coming to I equal to 0, and then coming to while loop, infinite while loop. Here you have a for loop. For loop starts from 0 to 1000. It goes up to 1023 I++. So set PWM duty cycle. So you are calling a function. The value of I is initially 0. So you are setting duty cycle as a 0. It means your T on time will be completely 0%. T off will be 100%. So you are setting 0. It means now LED will be completely off. Next you are incrementing 1, changing the value 1. Again for every time you are giving some delay 2 milliseconds. Okay. So now you are changing value 1. So now value is 1. So maybe 1, I don't know like how much the voltage with difference will be there. So it may be like very less, even though you cannot see any difference in the LED. So 2, 3, 4 like that. You are going from 0 to 1023. So every time you are calling the function and you are setting that value in the that particular 2 registers. Then once it is done, so once it is going from 0 to 1023, when it is going to 1023, you will see the complete brightness. Got it, right? When it is going 511, it will be off of the brightness because 2.5 voltage will go. When it is going 1023, it will be a complete brightness. Clear everybody? Next, that is done. Once the loop is completed, again it comes here. Now again from 1023, it goes up to 0. So now the brightness is reducing. So this both the loop is again inside the infinite while loop. So gradually it is increasing, this is gradually decreasing. Again increasing, decreasing. Clear? So overall experiment is only that much. And setting that function already we have seen. Now coming to this configuration. So PWM you are going to configure in these 3 register. So for configuring the PWM you need to follow this procedure. So PWM is nothing but it is a wave. Already we discussed, right? The PWM wave is generated, maybe it can be 50-50 or it can be any other form, but it is generated as a, like a one frequency. It is generated. So for that you need a timer, because using timer only this much time it should be on, this much time it should be off. Internally PWM is using the timer. So it will make on for this much millisecond or microsecond, and this much millisecond, microsecond it will make off, on, off, on, off. So that what we have to do is we have to use the timer. So you have to enable the timer. Got it, right? So for PWM we are using timer 2. Okay, in this PIC controller PWM you are using it, you have to use only timer 2. For regular time related or any delay generation, now that time you will be using timer 0 for regular purpose. But coming to the PWM, you have to use only timer 2. Timer 2 is associated with the PWM. So turn on the timer 2 in T2 con register. Okay. So T2 con register we have in this. I have skipped up. This is unused. These 3 bits are like we are not using now, so that I am not mentioning anything. Okay, I don't want to confuse you people. Which and all is important, only that I highlighted. Which and all is not important for this discussion, I am not highlighting it. So these all I am ignoring it. TMR2 on. So timer 2 you have to enable it. So it means this bit you want to make it 1. Okay, so this if you are making 1, the first step is done. So this you are making 1. Next, set the timer to prescaler. Already we have seen in the timer class, whenever timer you are using, you have to use the prescaler. Otherwise, like a timer will not able to keep counting it. So when you use the prescaler, it will divide the count. Got it, right? That's it will try to reduce the overflow rate. So that's the purpose of using timer. So that's the purpose of using prescaler. So prescaler timer you are using it, definitely you have to configure the prescaler. For timer 2 prescaler, where you are configuring in these 2 bits. T2 stands for timer 2, CK stands for clock, timer 2 clock, PS stands for prescaler. Timer 2 clock prescaler 1, timer 2 clock prescaler 0. So using these 2 bits you are going to configure what prescaler rate you want. In timer 0, what prescaler we set? Anybody able to recollect? Timer 0, when we used what prescaler rate we set? One is to 256. Got it, right? 1 is to 256 we said. Here we are setting just like a 1. 1 is to 1. So these 2 bits like we are going to make it 0 0. Got it, right? So these 2 bits we are making 0 0. Always compare so that you will not get confused. In timer 0, like a prescaler, that they are like I think you use 3 bit or 2 bit. 3 bit you use for the prescaler, but here you are using only 2 bit. So here you are using 0 0. 0 0 means 1. So 1 is to 1 is the prescaler rate. So this will be the configuration of your timer 2. So now you done with the 2 configuration. Correct? You are turning on the timer 2 and setting the prescaler. So now what is the hexadecimal value? 10. 0x40. Okay, so this all should be 0. 0x04. Got it, right? So T2 con is 0x04. So we done with the first 2 configuration. And coming to next, set the PWM mode in CCP1 con register. Okay, again now you are setting the mode. See, already I told the CCP1 and the CCP2 will work in 3 different modes. What are the 3 different modes? Capture, compare, PWM. Got it, right? So it can be used for capture purpose also, it can be used for comparing purpose also, it can be used for PWM purpose also. What we are using here is PWM. Okay. So you see here, these 4 bits are used to configure these 2 pins for PWM purpose or capture purpose or compare purpose. Very simple. These 2 pins are there now, CCP1 and CCP2. This we are going to use it for PWM means, then you have to configure here. So what is the configuration is 0 0 0 0 1 0 0. So all these are for capture and compare. So I am not bothered much. So I am given capture, compare, something like that. Okay. So till this it is same. only double one anything. When the number starts double one XX means double one double zero, double one zero one, double one 10, double one 11. So these all are PWM mode. So you can set double one double zero, double one all 11. Anything you set, by default it is a PWM mode. In that PWM mode itself, again there will be some more like options will be there. Got it, right? So we are going to set only 1100. This will be 1100. In your 1111, see if you give all 4 bits are 1 on 11 also, it is okay only, no problem. And these 2 bits as of now we are not using, so just I am making it as a 00. It's clear? So PWM mode you are setting in the CCP 1 con register by making this 4 bit as a 1100. Remaining 4 bits are like we are not using for now, so that we are making it to 000. So the third configuration is done. Clear, everybody? Okay. Next, coming to fourth, set the PWM frequency in PR2 register. Now, the PWM, what the wave is generated, right? That PWM wave in what frequency we want. Whether it is a 10 kilohertz or 100 kilohertz or 1000 megahertz, whatever it is, that you want to set. So for that, we have a formula. Okay. So the formula is this one. PWM period is equal to PR2 plus 1 into machine cycle into TMR2 prescaler. So almost a similar formula like what we have seen in the timer. In timer also I think we have seen similar. Got it, right? So maybe here some changes will be there. Okay, rest all is like here also machine cycle and the prescaler PR. Okay. Now what is PWM period? Formula is this. So your formula is this. For this only we are doing all of these exercises. See, machine cycle we know. Last class itself we discussed. Machine cycle is 200 nanoseconds. And prescaler we know. Prescaler is just 1 because we configured only 1. So we know this machine cycle, we know the prescaler. We don't know PR2. PR2 only we are going to calculate. What is PWM period? PWM period is nothing but 1 divided by PWM frequency. Okay. So now we are only going to set what frequency we want. So as of now I am taking as a like a 19.53 kilohertz. So that frequency, in that frequency I am expecting the PWM output. The expected output frequency is 19.5 kilohertz. So it means 19.53 into 10 to the power kilohertz means 3. So 10 to the power 3 means 919,530. Correct, right? So 19,530 clocks will be generated in 1 second. Got it, right? So in 1 second of time, 19,530 clock will be generated. In that, according to your T on and T, according to your T on, let's take T on is 50. Then on, off, on, off. So this is 1 clock. This is 1 clock. So like this, total 19,530 clock will be generated. If it is on time is more, that much like on time will come. I mean, if on time is like as let's say duty cycle is 70, then it will vary. So it will go like this. So 70% of on, 30% of off will be there. Clear? So here I am just taking an example. the frequency of the PWM is like a 19.53 kilohertz. So that the finally like a 1 divided by 19.53 kilohertz, finally like you are getting 51.2 microsecond. It means, what is this 51.2 microsecond? Period means for one clock. One clock we are calling it as a one clock period, right? So to generate one clock, it need a 51.2 microsecond. Getting right, everybody? Previously we assumed if it is working in 1 hour means in 1 second it will generate only one clock. Now we have configured for 19.53 kilohertz, so that for one clock it will take time of 51.2 microsecond, or you can say other way, in 51.2 microsecond it will generate one clock. So like that, another 51.2 microsecond, another clock. Okay. According to your T on time, within that 51 microsecond, the ratio of T on and T off will vary. Everybody getting right? So if it is duty cycle is 50%, no? Then 51. Okay, let's take 50 microsecond. So if it is 50 microsecond, 25 microsecond will be on and 25 microsecond will be off. If it is a 50 T on, if it is like a 70 or if it is 75, then maybe 37.5. Okay, 37.5 will be on and 12.5 will be off. Clear? Okay. So the third one is you are setting the PWM frequency in PR2. Directly you cannot set. So what you are doing, there is a formula. In this formula, by substituting your like a PWM period is like a you are calculating using the frequency. So you got that, you are substituting here. PR2 we don't know, machine cycle and prescaler is substituted. So finally only unknown value is PR2. You will be generating PR2. PR2 has become 255. So that hexadecimal, it is FF. So that is what we are, that is fourth step. That is what we are setting here. So already we discussed this. Sorry. For this, what is hexadecimal? 0xC0. Sorry, 0C. And PR2 is like a 0xFF. Timer 2, T2 count already we discussed, that is 0x04. So the configuration is only that much. And the last step is set the 10-bit duty cycle value in CCP1 con under CCP R1L register. Okay. So you are calling and you are setting. Then your job is done. See here, the interviewer is not expecting all. Sir, they will not expect like which bit you are enabling timer to, which register you are enabling timer to. They will not go to that particular the name and particular bit and all. So don't worry about that. Just what you need to remember is what you are doing. If I am using PWM means I need to enable the timer 2. I need to set the timer to prescaler, and then PWM mode I need to enable it. Okay, and then the frequency you need to set, and finally you are setting the 10-bit duty cycle value. Got it, right? So that overall concept you need to remember. Nobody expects that like a which register. If you are able to remember, that is well and good. Again, don't like force yourself and don't feather. Sir, this ADC we discussed what register, ADCON. If it is able to recollect now, that is good. So ADC we discussed ADCON 0 and ADCON 1. ADCON 0, sorry, 4 configuration. ADCON 1 is 2 configuration. Because for me, I am keep practicing so that for me it is coming. If you are able to recollect, that is super. But at least like you are able to recollect like what configuration you are doing, that is good, that is needed, that is expected. Okay. And yeah, that's all. So coming to PWM, just to summarize, PWM is like using PWM we are going to generate the analog output voltage. Okay. So for that we have two channels in this PIC, channel 16 and 17, CCP1 and CCP2. CCP stands for capture, compare, and PWM. And how to configure it? So you need to configure it as like a 5 different stages. Enable the timer preschedule you need to set, mode, PWM mode you need to set the frequency and set the 10-bit value. Okay. So what actually internally is happening is you are going to set the 10-bit value. The 10-bit value is nothing but it is a duty cycle. So what is duty cycle? Duty cycle is in one clock we have a T on and T off. T on is called as a duty cycle. By controlling the T on, automatically T off will be adjusted. So how much ever percentage you are giving T on, according to that much percentage of output voltage you can expect in this PWM channel. Okay. I think that's it. Almost like we covered. Okay, now we can stop.